Hello students, today in this video another case of projectile motion is discussed. Here the projectile is thrown with some initial velocity u along the horizontal, that is along x-axis. Here it doesn't have any velocity along the y-axis. Okay, so at the initial time, that is at time t equals to 0, we can write the velocity along x direction to be u and velocity along y direction to be 0. Now here theta is 0. As you can see that the velocity is directed along the horizontal. That is, it is moving parallel to the ground. So naturally theta will become 0. Now as the body or the projectile descends, suppose when it comes here, its motion becomes two-dimensional. That is, it has a motion along the y-axis in the negative direction and also along the x-axis. That is, its v will be like this, which is making an angle theta with the horizontal. So as the body descends, its motion has two simultaneous independent motion parameters. Okay, so let us suppose that the body was thrown from the height h, having the initial horizontal velocity u, and after time t the body has come from the point O to the point P. Now as I told you that at time t equals to 0, x is 0 and y will be h because it is placed at a height h, and the velocity is only along the x direction, no velocity along y direction. Now after reaching the point P at time t, after it got projected, let us see what is the position of the projectile. The position is given by, along the x direction it is x, this much is x and this much is y from the ground. Okay, so x will be given by, x is a distance, so it will be given by speed into time along x direction. So u is the speed along x direction and time t. Now when we try to find out the y coordinate, this y coordinate, we are using the second equation of motion. Now why second equation of motion? As you can see that the body is making motion along y axis with some acceleration, which is the acceleration due to gravity. As the force of gravity g is acting along this direction, negative g, and the force of gravity is pulling the body towards the ground. So since the force is acting on the body along x direction, so there will be some acceleration along the y direction. But in case of x direction, in this direction no force, so ax will be 0, ax will be 0, and in case of ay it is minus g. Now let's come back to this equation. Here we insert uy equals to 0 and in place of ay we write minus g. Thus the y's value becomes minus half gt square. So if we put the value of time t here, we can get the value of y after putting t and g's value. Okay. Now we are trying to find out this velocity v at the position P after time t. So Vx will not change, it will remain as the initial velocity u, that will be Vx. Now coming to Vy, that is here as the diagram is showing, v is resolved into two components, Vx and Vy. Vx is u and Vy will be given by the first equation of motion, which is uy plus ay multiplied t. In place of uy I put 0 and ay minus g to get Vy equals to minus gt. So there are two types of motion in the two axes, along the two axes. In case of x-axis, uniform motion, and in case of y-axis it is uniformly accelerated motion. Now v is the resultant of Vx and Vy. So how to get v then? The magnitude of v will be given by root over of Vx square plus Vy square. So after squaring and adding, if we square root it, then we get the value of v, which is the velocity of the body at the point P. Now when it moves further, when it comes down further, here again the velocity changes because the angle changes, and here we again resolve into two components and get the value of v at that position. Okay. But see here, the velocity as it descends, the velocity keeps on increasing because it is an accelerated motion. So as the projectile is acted upon by some force, that is the force of gravity along negative y direction, here the motion of the projectile is uniformly accelerated and the velocity keeps on increasing. Next we are trying to find out the time of flight. What is that time? The time span between the point of projection and the point of, the time at which it was the time gap between the projection and the landing of the projectile is called the time of flight. So that is the time needed by the projectile to reach from O to the ground position. That is taken as capital T. We again use the second equation of motion to find the expression for T. Now, during the time interval capital T, that is the time of flight, the projectile has descended down vertically through a height h. So in place of y, we can put h. In place of uy, it is 0 multiplied the time of flight, and in place of ay again minus g multiplied t square. So that gives us h equals to minus half gt square. So if we take only the magnitude, t square will be 2h by g and t will be root over of 2h by g. Now to find the horizontal range, as you all know that horizontal range is the distance between the point from where it is projected to the point where it touched the ground or the projectile landed. So here the parallel point of O will be this, let's say O dash. So from O dash to say a point x, O dash to x, this will be treated as the range. So r is equal to ux multiplied t. R is distance. Distance can be obtained by multiplying the velocity and the time of flight here. So ux will be u. Now we substitute the value of t. So we get r equals to u multiplied under root 2h by g. Now coming to finding the equation of the trajectory of such projectiles where it is thrown from a height with some initial horizontal velocity, I am first writing the trajectory equation for the projectile when it was thrown with some initial velocity making an angle theta with the horizontal, that is, it was not thrown horizontally. So if you remember, the equation of trajectory was y equals to x tan theta minus half g into x square by u square cos square theta. Now here in this case, in this equation only, if we put theta equals to 0, because here initially the velocity is not making any angle, so theta is 0. So in place of theta, we can write theta equals to 0. Here also theta equals to 0. By doing so, we get y equals to 0 minus half g by u square multiplied x square. So y is equal to minus half g by u square x square, which is the trajectory equation for this case of projectile motion, and it is evident that it is the equation of a parabola. So here also we can say that the trajectory of the projectile is in the shape of a parabola. So if you want to summarize the equations once again, then at t equals to 0, x equals to 0 and y equals to h, then ux is equal to u and uy equals to 0. Okay. Now at t equals to t, that is after time t has elapsed since the body was projected, x is given by u into t and y is given by minus half g t square, and Vx will be u and Vy will be minus gt. Therefore, V will be given by under root Vx square plus Vy square, that is u square plus g square t square. Next we have time of flight t equals to under root 2h by g, and horizontal range r will be given by u into t, that is u multiplied under root 2h by g, and lastly the trajectory equation will be half g x square by u square, as you can see over here. Okay, so this will be the trajectory equation. Hope this video will help you to solve numericals based on this type of projectile motion. That's all for today in this video. Hope to meet you soon with another video dealing with all the numericals based on different types of numericals based on different types of projectile motion. Till then, keep studying, stay fit, and thank you all. Bye.